Okay guys, free fall. Something we've really talked about a lot in this class, but I really want to get back into it for a brief moment. Free fall. And free fall is whenever we drop something, like if I just had an object in my hands, like a priceless mink vase, and I just dropped it. So the important thing, guys, with free fall is that your VYI in the Y direction is always 0. And usually in the X direction for the velocity is 0 as well, but it just drops. And we also know that our AY is G. As long as we're on the planet Earth, then it's usually going to be negative 9.81 meters per second squared. And you could also say this is negative G. I don't know. It's whatever. It's pretty arbitrary. Just remember the acceleration Y is always negative 9.81 meters per second squared. Okay, and a couple important things as well. Your D is usually a negative value, some negative value, meters. And what else? Your VYF is usually also a negative value, but meters per second. Okay, so we've got this. This is generally free fall. But why are we coming back to this? Well, I want to think about it in terms of force. So like, as an object drops, what happens? Well, we know one thing. The initial velocity is 0, so I'm gonna make a dot. Let's bring up my colors though. I will make my velocities purple. So let's go a series of time intervals. So we've got t0 times 0, it's dropped. At t1, that's 1 second. t2, and then t3. I might as well fill up the space in space. Get you guys what you paid for. So as we know, and this is our velocity, purple's going to be velocity for us. That's not going to fit. Look at V. Okay, as we know, as an object falls, its velocity gets larger and larger, right? So here, should probably hold the shift key down, here, and here. And these are just arbitrarily drawn. I mean, I guess if you had higher expectations, maybe you'd expect them to be a proper length, but I'm just being pretty lazy tonight. So guys, as an object drops, its velocity is going to increase. And in fact, guys, a pretty interesting fact to me is that if this is 0 meters per second, this is going to be negative 9.81 meters per second. And then this one would be 19.62 meters per second. And each one of these guys, for every second, it's going to be going that much faster. Negative 9.81 meters per second squared faster, or meters per second faster. So that's a pretty cool fact, but not 100% necessary for right now. Now, an interesting thing, guys, also, as something falls, it starts to run into more and more air molecules. Almost just like if you're to run down the hallway, you're going to run into a lot of people. In fact, there's a certain speed where you just can't run any faster because you can't dodge people fast enough and people can't dodge you fast enough. So there's a maximum speed that you can go down the hallway because of the people. But there's also a maximum speed for objects falling in the Earth's atmosphere because it keeps running into these air molecules. Now, the interesting thing is you may say, well, Mr. Shaw, what if we remove the air molecules? You'd have a vacuum, and there wouldn't be this maximum speed. But let's take a look at the force. Let's stop right there and let's look at a force. Now, remember, guys, everything is pulled down by the force of gravity. I'm going to remove my velocity thing. I hope you guys, maybe I'll draw it someplace else. Velocity. It's purple. Now we're going to get to our next one where FG is going to be a light blue. And I'm going to put it a little bit off to the side. Now the one thing important to realize about FG, guys, oh, that's not what I wanted, is that FG, did that work? Yeah. FG is just always going to be the same. Oh. So no matter what time an object has been falling for, the force of gravity is always going to be the same. Here's your force of gravity here, here's your force of gravity here, here's your force of gravity here. It's always, 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 we'll move a little closer to there velocity vectors so we can pair them up a little better. But our forces always stay the same. The force of gravity is always the same on an object as it falls. And that's pretty important because gravity is going to be what pulls us down. But I just said something. The faster we go, as we start here, we go faster and faster, we start running into more air molecules, we're going to have another force that's going to start to become ever more so important. What is that force? Please switch back to blue. There we go. So what is that force? Well, it's the next force. It's going to be the force of gravity, or not the force of gravity, the force of friction. And air friction to be exact. So as we fall faster and faster, a new force starts to arise. Starts off very small because we're going very slow. In fact, when we start off, it's going to be just a point. But as we go faster and faster, this force is going to get bigger and bigger. Actually, I'm going to make it very small. Bigger and bigger and bigger. And eventually, at some time, it doesn't have to be 4 seconds, it's going to be equal but opposite to our force of gravity. Do you see that this last case is extremely important? Because we have a force of air friction equal but opposite to our force of gravity. And they're going to cancel out. They're going to be at equilibrium then. And when we have equilibrium at this last moment, it's extremely important. At this last moment, at the very end, we have equilibrium. Now, a lot of people always want to say, well, in midair you stop. You don't just stop in midair, guys. You know better than that. You keep falling. You continuously, if you just keep falling long enough, you don't just stop and you're suddenly safe and you can fly away. No, you reach equilibrium, not stopping, constant velocity. So you're falling towards Earth, but you're no longer accelerating. You have a constant velocity towards Earth. You're not speeding up anymore, but you're just going faster and faster. And what we call this, guys, this has a very important word. It's called the terminal velocity. It's your final velocity. That's what terminal means. Just like Grand Central is a terminal. It's Grand Central Terminal. It's the last stop for a bunch of trains. It's not Grand Central Station. It's Grand Central Terminal. And that's why it's stressed. It's a terminal. That's where the trains end. It's the last destination. This is your last velocity. When somebody's very sick, you say they're terminally ill. That means that's the last illness they're going to have for the rest of their life. That's their sickness that's going to kill them. Very sad, I know. And this is the velocity that's going to kill you, I guess, if you fall and you don't have a parachute. Okay, guys, hopefully this gives you a little bit better idea. If you've got any questions about free fall and what happens with air friction, it builds up over time. Gravity stays the same, and eventually air friction becomes equal but opposite to gravity, the force of gravity. Now, why does air friction build up? Because your velocity builds up. As your velocity builds up, very important. I guess I should really stress this. As velocity increases, so does air resistance. Okay, and let's think about that, guys. Shoot me any questions. Thanks for